And again, this will be available on Canvas by midnight tonight. So for the rest of chapter 16, we need a formula for conditional probability and lots of practice. So conditional probability will adjust the probability of an event. So we're still recording the meeting that we started. We are going to try to get through today's examples, but it's just been a bit of an issue with the internet this morning, so we'll see how this goes. Okay. So, conditional probability adjusts probability of an event. Let me see. Based on information from an event that has already occurred. So on some different event that already occurred. So for conditional probability, we're going to have some notation. It's P for probability. Probability of A given B will be A. So this is the new formula. Probability of A given B is equal to probability of A intersect B, and then divide by the probability of B. So whatever event is in this second spot, that's the one that you need to divide by that probability. So you know, like based on the information that event B has occurred, you want to know about event A and what that probability is. And you know that extra information from event B. So that's the last main focus for chapter 16, and we'll just do a lot of examples and probably a few more examples at our next meeting, and then start chapter 17. Okay. Let's roll. And this was roll a fair six-sided die. Find the probability of getting a 2 given that the roll was even. So we'll have event A be getting a 2. And then the roll is even. Even numbers will be event B. I would like to draw the picture or draw the Venn diagram. So we have a 6-sided die. The space has the numbers 1 through 6. Start with S. A and B are subsets of S. Okay. 2 is common to both sets, so it needs to be here where it's in A and B. Okay, it's good. B also contains 4 and 6. 1, 2, 3 somewhere. 4, 5, 6. Okay. Next one. I need probability of 2 given that it was even. So A given B. Probability of A given B, we'll put the formula up here again. It's probability of A intersect probability of B. The probability of A intersect B divided by the probability for B. Okay. So A intersect B contains 1 outcome, and so its probability is 1 out of 6. Okay, probability for B. B contains 3 elements, and divide by the full space to get its probability. Divide by the number of outcomes in the full space. take that top fraction, divide by another fraction means we multiply by the reciprocal of that bottom fraction. Okay, 6 over 6 reduces to 1. So you'd have a 1 here and a 1 there. 1 times 1 equals 1. 1 times 3 equals 3. So we've gotten the answer from using that formula. But we'll talk about getting the answer by thinking through what's happening. So you're told that event B has occurred. So we restrict the sample space and block out everything else. Well, there you go. Now, how often does A occur, or what's the probability of A given B? It's the number of outcomes from A out of the number of outcomes from B, 1 out of 3. As long as you restrict the sample space and then you take how many times A can occur from just that space and then divide by the total number of elements in that set. We're going to still practice using the formula. Next one. S contains 1 through 9. A has the elements 1, 4, 6. B contains 2, 3, 4, 6, 9. First, we'll draw the Venn diagram. We'll have A and B contained in S. I would see what elements are common. We've got 4 and 6 common to both sets. I go into that part. We also have that element in A. 2, 3, 9. Okay. 1, 2, 3, 4, 5. 6, 7, and 8. And 9. Are A and B disjoint? A and B are A and B are not disjoint. They share common outcomes. Apologize. Okay. These two outcomes. Okay. We share out common outcomes. Oops, we already did that part. And again. Find the probability of A union B. So it would be the number of elements in A or B, which is both sets together. 1, 2, 3, 4, 5, 6 elements. And then divide by the total number of elements in the space. So 2 times 3 over 3 times 3. 3 over 3 reduces to 1. And have 2/3. Part D. Find the probability of A given B. We have that formula. It's A given B equals the probability of A intersect B divided by the probability for B. I just want to keep the picture, so we'll make it work out right here. Okay. A given B. Probability A and B divided by probability for B. Whatever sets in the second spot. That's one that goes there. So each probability will be a fraction. The first one, the probability of A intersect B, is going to be the 2 outcomes from A intersect B divided by all 9 possible outcomes. Okay, and probability for B. B contains 1, 2, 3, 4, 5. So you have 2 ninths and then multiply by 9/5. 9 over 9 is going to reduce to 1. So 2 times 1, which will be 2. And 1 times 5 is 5. So that's your answer using the formula. But we could kind of think through what's happened to get to that number. So A given B, you restrict your outcomes to set B. So everything else gets. Okay, hopefully you can hear me. And we're back. I'm going to go back through that explanation, but before we do, I just want to say thanks for hanging in there through this online semester. And thanks for being patient with my internet connection and our kind of like piece together meetings, but we're still recording and we're still good to go.